Hello everyone. In this class I will tell you how to convert a word problem on the topic speed, distance and time in a easiest way. Okay. So look at the formula, the basic formula that we required to solve the questions, that is distance is equal to speed upon time, or we write simply speed is nothing but distance upon time. So in most of the question we have to find out the time. So time is nothing but distance upon speed. So remember only this one formula, time is equal to distance upon speed. In the end we will use the time of the slower minus time of the faster. That difference in most of the question, difference will be given. So time of the slower minus time of the faster is equal to time difference, whatever is there. And suppose in the question 30 minutes like this is given, always convert into hours. So 30 minutes means half an hour, like that. Okay, so to find out quadratic equation we have to follow that 4 steps. First of all, whatever we have to find out, consider as x, then make the table. I will tell you how to make the table. Then use this above time difference equation and just do the cross multiplication, and then we'll get the quadratic equation. So look at the question number 1. So you have to see in the last what we have to find out, find the original speed of the train. Okay, so whatever we have to find out, consider as x. So let us consider, let the original speed of the train is equal to x kilometer per hour. Okay, now I'll tell you how to make the table. So we'll use here speed, distance and time. Okay, so there are two speeds, one is original and one is after increase. What is the speed? So first of all, identify the terms from the question. A train travels 360 kilometer. Okay, so this is the distance, 360 kilometer. So distance is 360 at a uniform speed. If the speed had been 5 kilometer more per hour more, it would have been taken 1 hour less. Okay, so this 1 hour less is nothing but the time difference is given. So we have to find out the original speed of the train. So let us consider the old speed is here the old speed and here the new speed. So we have considered the original speed, which is old one, that is x. Okay, so in the column of speed the original speed is x. Now what is the new speed? So in the question it is given that if the speed had been 5 kilometer per hour more, so old speed is x, so new speed will be what? X plus 5. Okay, because it is increased by 5. The second column is the distance, so distance is same, 360. Here also distance is 360. Then we have to calculate time. So what is the formula for time? Time is nothing but distance upon speed. So when we are going for the with the old speed, what is the time? Distance is 360 upon speed is x. So time is 360 by x with the old speed. And what is the time taken by the new speed? Distance is 360 upon speed is x plus 5. Okay. So this is the time of the slower one, and this is the time of the faster one. So time difference is given 1 hour less. If you increase the speed, time is less. Okay. Just now above we have seen the equation how to subtract the time. Time difference is given is equal to 1 hour. So which 1 hour it is? Time of the slower minus time of the faster. So the time difference is given 1 hour. So what is the time take of the smaller with the smaller speed, old speed? 360 upon x. So 360 upon x minus what is the time when the new speed is there? 360 upon x plus 5. So we'll put 360 upon x plus 5 is equal to 1 as it is. Now we can see that in numerator 360 is common here and is as well as here. So if we take 360 common outside, so what will remain inside the bracket? 1 upon x in the first term minus in the second term 1 upon x plus 5 is equal to 1. do the cross multiplication. So if we do the cross multiplication, we'll get 360 inside the bracket x plus 5 into 1, which is x plus 5, minus x into 1, which is x, divided by x into x plus 5 is equal to 1 as it is. So in the numerator, this x and minus x will get cancelled. So it will remain 360 multiplied by x 5 upon, if you multiply the denominator, x into x, x square, plus x into 5, 5x is equal to 1. Now again we have to do the cross multiplication. So this x square plus 5x we have to multiply here. So 1 into x square plus 5x, which is x square plus 5x, and in the left hand side 360 multiplied by 5, which is 1800. So if we take this 1800 that side, so we'll get our quadratic equation x square plus 5x minus 1800 is equal to, we can write down 0. So this is our required quadratic equation. So you have to solve this quadratic equation by using factorization, or you use quadratic formula method, and then we'll get the value of x, that is the original speed of the train. Okay. So in this class I will tell you how to convert and how to make the quadratic equation, that much only, and this you have to solve by using the quadratic equation method or factorization method. Look at the second one. A flight of 600 kilometer is delayed by 30 minutes. Okay, so this 600 is nothing but the distance is given, and time is given 30 minutes due to bad weather. To reach its destination on time, the speed must be increased by 200 km per hour from its usual average speed. So find the usual average speed of the flight. So the same thing you have to consider, let the usual speed of the flight, okay, let the usual speed of the flight is equal to x kilometer per hour. So make the table speed, distance and time. Okay, so distance is same 600 kilometer with the old speed and with the increased speed. So in the starting we have taken the old speed, let's say x kilometer per hour, which is old speed. So how much speed is increased? Increased by 200 km per hour from its usual speed. Okay, so old speed is x, so new speed will be what? X plus 200, increased by 200, no? So x plus 200, so this is a new speed. So calculate the time. Time is given by what? Distance upon speed. So for the old one, what is the time? 600 upon x. This is the time taken with the usual speed. And what is the time for with the new speed? 600 divided by x plus 200. Okay, so what is the time difference? If it is going with the usual speed, then it delayed by 30 minutes. Okay, so that 30 minutes is nothing but the time difference, which is given 30 minutes. So 30 minutes means 1 upon half. So we'll subtract the equation, time of the old speed minus time with the new speed is equal to time difference. So time difference is given 30 minutes. 30 minutes means 1 upon 2 hour, 1.5 hour. What is the time taken with the old speed? 600 upon x minus time taken with the new speed, 600 upon x plus 200. So again the same thing, what is common in the numerator? 600 is common. So if we take 600 common, so what will remain in the first term? 1 upon x, minus in the second term what will remain? 1 upon x plus 200 is equal to 1 by 2. So 600 as it is. If we do the cross multiplication, so x plus 200 into 1, which is x plus 200, minus x into 1, which is x, upon x into x plus 200 is equal to 1 by 2 as it is. So in the numerator, x minus x will get cancelled. So 600 into 200 is remaining. So 6 into 2, which is 12, and then 1, 2, 3, 4. 4 zeros are there. upon, if you multiply x into x, it becomes x square plus x into 200, which is 200x, is equal to 1 upon 2. So if we do the cross multiplication one more time, this 2 will come here in the multiplication. So 2 into 12, which is 24, and the remaining 40 as it is equal to x square plus 200x multiplied by 1. So if we multiply with 1, it will be the same thing, x square plus 200x. Then take this 24 and 4 zeros that side. So x square plus 200x minus 240000 is equal to 0. So this is our required quadratic equation. You can solve by using quadratic formula method to get the final answer. Next question. The question is on about train, express train versus passenger train. Okay, so the question is, an express train takes 1 hour less. So identify what is this. This is nothing but the time difference. 1 hour less is given. So time difference is given 1 hour to travel 130 kilometer between two stations. So this is given to be distance 132 kilometer. If the average speed of the express train is 11 kilometer per hour more than that of passenger train. Okay, so the speed of express train is given in terms of passenger train. So find the average speed of both the train. Okay, so what is completely unknown in this question? In this question we don't know anything about the passenger train. So let us consider, let the speed of average speed of passenger train is equal to x kilometer per hour. So we'll make the table here, speed, distance and time. So here if I write passenger train and second one is express train. So for passenger train, the speed we have taken x kilometer. Distance is what? 132. So for distance for the other train is also 132. And what is the speed of the express train? So it is given the average speed of the express train is 11 km per hour more than of the passenger train. Okay, so passenger train speed is x and 11 km per hour more for the express train. That means x plus 11 speed of express train. So we will find out the time for passenger train, that will be distance 132 upon speed x, and time taken by express train, which is 132 upon speed, which is x plus 11. So what is the time difference given? 1 hour less. Okay. So time of the slower speed minus time of the faster train is equal to time difference. So which train is slower? Passenger train. So what is the time? 132 upon x. 132 upon x minus time of the express train, which is 132 upon x plus 11 is equal to, time difference is given 1 hour. Okay, 1 hour less means time difference is given 1 hour. So same thing, 132 will take common. So inside the bracket 1 by x minus 1 upon x plus 11 is equal to 1. Do the cross multiplication. So 132 into x plus 11 into 1, which is x plus 11, minus x into 1x upon x into x plus 11, which is x square plus 11x is equal to 1. So in the numerator, same thing, x minus x will get cancelled. In the numerator we have to just multiply 132 into 11. So if we multiply 132 into 11, we will get 1452. Denominator x square plus 11x as it is equal to 1. So multiply it again, x square plus 11x into 1, which is x square plus 11x. And this side we have 1452. Take to the right hand side, so x square plus 11x minus 1452 is equal to 0. So this is our required quadratic equation for this given question. Look at the next one. A student cycled to a town 24 km away. So this is a nothing but a distance is given 24 km. If they had a cycled 2 km/h faster, okay, so this is a nothing but increased speed, they would have taken 1 hour less. So this 1 hour less means time difference is given to cover the same distance. So find the speed of the original speed of the cycling. Okay, so let us consider, let the original cycling speed is equal to x km/h. So make the table speed, distance, time. What is the distance? 24 km. So distance is same. So original speed and new speed. Original speed we have considered x. What is the new speed? If the speed is increased by 2 km/h more, faster means addition. So x plus how much? 2 km/h. So new speed is x plus 2. So what is the time? Time taken with the old speed is distance, which is 24, speed is x, and time taken with the new speed, which is distance upon speed, so 24 upon x plus 2. So time difference is given 1 hour. So time of with the old speed, time with the new speed is equal to time difference. So for the old speed, time is 24 by x minus with the new speed 24 upon x plus 2 is equal to time difference is 1. 24 is common, so if we take 24 common, inside the bracket 1 by x minus 1 upon x plus 2 is equal to 1. So 24 inside the bracket x plus 2 into 1, which is x plus 2, minus x into 1 x upon x into x square plus x into 2 2x is equal to 1. So in the numerator x minus x will get cancelled. 24 into 2, which is 48, and if you multiply this x square plus 2x with 1, you will get x square plus 2x. Take 48 this side, so we'll get x square plus 2x minus 48 is equal to 0. So this is our required quadratic equation. Solve by using factorization, you will get the original cycling speed. So this is a practice homework question for you. Try with the above table and same steps. Find out the quadratic equation for both the question and comment your answer in the comment section. Thank you.